Hello, geometry students. Mr. Zacek back and better than ever here in Unit 4, Lesson 3. Okay, and right now what we are doing is we're building our methods for proving triangles congruent. All right, so just a quick little review. The methods that we have talked about so far are side angle side and side, side, side. Those are the two. And we're going to add two methods to that today. We're going to add angle, side, angle postulate, and we're going to add angle, angle, side. So when you look at this, all right, let's look at the first one, angle, side, angle. I want you to notice the position of the side in relationship to the angle. So angle, side, angle. If two angles and an included side of one triangle are congruent to two angles and an included side of another triangle, then the triangles are congruent. So the key here is recognizing that included side. So the order matters. So as you look at this diagram, what we see here is that side AC is between angle A and angle C, and side DF is between side D and side F, and those are the two angles we know on the side. Kind of the ends of the side here, the endpoints of the side are the vertex of the two angles that you know. That's how you know that it's an included side. So this would be angle, side, angle, congruent to angle, side, angle. That's the reason. So if you go clockwise or counterclockwise along your diagram, you get angle, side, angle. Okay, not to be confused with angle, angle, side. So now notice that the side comes here at the end after the two angles. So if two angles and a non-included side of one triangle are congruent to the corresponding two angles and the corresponding non-included side of another triangle, then the two triangles are congruent. So as you look at this, we've got angle A and angle B congruent to angle D and angle E, and notice that side AC and DF is not included. Okay, so this is the non-included side or sides, meaning they're not between the two sides, and they have to correspond with each other. Okay, so when that happens, we can use that as a reason. So we've got 4 reasons now that we can utilize for our proving triangles congruent. And so in the examples we're going to do today, we're going to focus on angle, side, angle, and angle, angle, side, and how to recognize the difference. All right. If you don't have your proof terminology sheet out, get that out. Okay, that's going to be helpful for us as we go through here. And so let's remember here, what's our approach to this? Our approach is to mark our givens. Okay. Step 2 is to look for our freebies. All right. Step 3 is to come up with a plan, and then step 4 is to execute the plan. Okay, so all right, so here's what we got. AD bisects BE. Okay, now remember it's BE that is being cut here. So BE is the one being cut into 2 congruent parts. And then we've got AB is parallel to DE. Well, from a proof terminology sheet, we understand that parallel unlocks something about angles for us, okay? And so we could say that angle B and angle E are congruent because they're alternate interior angles, all right? We could also say angle A is congruent to angle D, or with our freebie, we could notice that we have congruent vertical angles. All right, and so I'm going to go ahead and do that. And then my plan for this is going to be, now notice here, it's angle, the side is included. The endpoints of the sides are the vertex of the two angles that we have. And so as a result of that, I'm going to go ahead and use angle side angle. Now we could do this with angle angle side if we said A and D were congruent. Okay, and sometimes there's more than one way to go about doing these proofs, but I'm going to do it this way for now. So let's go ahead and bring in our givens. AD bisects BE, and AB is parallel to DE. Now I've brought both of those in, but none of those are a congruent statement. So I haven't done anything yet other than kind of the step that gets me to the next step. So here's what I'm going to do next. Let's start with saying angle B is congruent to angle E, and angle B and angle E are alternate interior angles. So it's if two lines are cut by a transversal, and parallel, transversal spelling, and parallel, then alternate interior angles are congruent. So what have we accomplished there? Well, we've got ourselves an angle congruent to an angle. So that's one step of the process. And, you know, just to follow along in order, not that we have to do this one next, but let's get the side next. Okay, the side comes from our bisector, and we can say that BC is going to be congruent to CE. And the reason for that is the segment bisector one. So if a segment bisects a segment, you can read this right off your proof terminology sheet. If a segment bisects a segment, then it divides the segment into two congruent segments. Okay, and we got our side congruent to our side with that step. Okay. Now again, as I noted before, the last angle pair you could get multiple ways. Because of the plan that I've chosen, I'm going to use vertical angles here. So I'm going to say that angle ACB is congruent to angle ECD. And the reason is, if two lines intersect, then they form congruent vertical angles. If two lines intersect, then they form congruent vertical angles. Don't forget the congruent part, don't forget the vertical angles part there. Okay, so we have here an angle congruent to an angle, and we've executed each step of the plan. And so now we can go ahead and say our final thing, which is that the two triangles are congruent. So that would be triangle ABC congruent to triangle DEC. And the reason is that angle side angle is congruent to angle side angle. Okay, so let's go ahead and try a couple more. All right, I think we've got, what do we got? 1, 2, 3 more. All right, let's see if I can move a little quicker. All right, so we're going here and we've got our givens, which is P is congruent to S. R is the midpoint of PS, which would give these segments here. And that's what we're given. Well, what do we got for free? We got our vertical angles here and here. And seeing as how we need to add some other letter, PQ, let's call this Q. Should have had that in there. Okay, so what could our plan be here? Well, angle, side angle. Notice that the ends of the segment are the vertex of the angle. So that's angle, side angle, congruent to angle, side angle. Okay, let's go ahead and do this plan. All right, so number one, angle P congruent to angle S. All right, and R is the midpoint of PS. Okay, given. All right, so let's get the side then. We're going to say PR is congruent to RS, and that's from the definition of a midpoint. If a point is a midpoint, then it divides a segment. If a point is a midpoint, then it divides a segment into two congruent segments. Divides a segment into two congruent segments. Okay, and we got to get our last angle, which is going to be our vertical angles. Angle QRP, congruent to angle SRT. That's our freebie. If two lines intersect, then they form congruent vertical angles. If two lines intersect, then they form congruent vertical angles. All right, so have we executed the plan? We've got in step one, a angle congruent to an angle. In step two, we've got a side congruent to a side, an angle congruent to an angle. Check, check, check. Okay, so we can say that triangle PQR is congruent to triangle STR, and the reason would be angle, side angle, congruent to angle, side angle. All right, let's keep rolling. Angle G is congruent to angle N. HK bisects GKN. So that means this angle here and this angle are the same. That's what we're given. This time the segment is bisecting the angle. Okay, what do we got for free? Well, we've got a common side. Now here we notice that are the vertex of the angle the endpoints of the side we know? No, they're not. So instead of angle, side angle, this is angle, angle, side would be our plan, congruent to angle, angle, side. Okay, so that's really kind of a key part here, that you are able to recognize that that side is the non-included side. All right, so let's go ahead and let's execute the plan. Angle G congruent to angle N. Okay, HK, a segment, bisects angle GKN. All right, given. What have we accomplished? We've accomplished an angle congruent to an angle. Okay, so let's get the second angle. Well, this bisector, the segment that's bisecting it, is going to create two angles. So the first angle would be GKH, congruent to angle NKH. Sometimes people number those angles. If you draw it on the diagram, that's fine to do it. All right, so if you look on your proof terminology sheet, you look at the segment or the angle bisector one. It's if a segment bisects an angle, then it divides it into two congruent angles. Into two congruent angles. And what we did here is we got an angle congruent to an angle. So we got the second part of our plan. We need the third part of our plan, which is one of our freebies. It's a reflexive property. So we have HK congruent to HK. Don't forget the segment bars there. Don't forget the angle symbols. All those little things matter. That's the reflexive property. All right, that's a side congruent to a side. So we've got all the statements that we need to use our reason and say triangle GKH is congruent to triangle NKH, and it's angle, angle, side, congruent to angle, angle, side. All right, one more. Okay, we're on our last one here, and let's go ahead and kind of start with marking our things. We've got D as the midpoint of CB. Okay, a midpoint divides a segment into two congruent segments. We've got perpendicular lines, which are going to create right angles. I'm going to name them 1 and 2. And we've got DA bisects angle CAB. So I'm going to call this angle 3 and angle 4 just to give you an idea of how we can number it. Okay. All right. And so my plan for this one is going to be angle, angle, side, congruent to angle, angle, side. Now, somebody's sitting there watching it and they say, wait a minute, Mr. Zacek, we could do the reflexive property and say that AD is congruent and we could do this one by side, angle, side. And you are absolutely correct. But just to help you, show you some variety and some different ways that you can do things, we're going to do this one with angle, angle, side. All right, so let me get cranking here on this one. I want a blue color. Okay, so I'm going to start off with just doing this one here by bringing in things a little bit of different timing just to keep you kind of fresh about not all the givens have to come in at the same point. So I'm going to say that this is DA bisects angle CAB, okay, and that's given. Some people teach it, bring the givens in when you use them. So this is angle 3 congruent to angle 4 from that given. So if a segment bisects an angle, then it divides it into two. Okay, then it divides it into two congruent angles. All right, so there's an angle congruent to an angle. Now the second pair of angles, angle 1 and angle 2, we're going to get from the perpendicular line. So I'm going to bring in AD is perpendicular to CB. Given. Again, you could have brought all these in earlier. I'm just showing you some variety, because if you don't see it like this, sometimes people just forget and then they have a fill in the blank one on a test and they just make some simple mistakes because it's just a given brought in later. So if you're following your proof terminology sheet, the first thing we say is angle 1 and angle 2 are right angles. Okay, and that's if two lines are perpendicular, then they form right angles. If two lines are perpendicular, then they form right angles. Form right angles, okay? And then we're going to say in step 5, angle 1 is congruent to angle 2, and the reason is all right angles are congruent, okay? So we've got an angle congruent to an angle. How are we doing on our plan? We got two pairs of angles, okay? We need the side. Well, the side is going to come from the midpoint, so let's bring that in. D is the midpoint of CB, okay, given. And then we just do the definition. We say CD is congruent to DB. All right, this is our definition of a midpoint. If a point is a midpoint, then it divides a segment into two congruent segments. Okay, so that's a side congruent to a side. So we've done all the pieces of the plan there. And so the last thing then we would say is that triangle CDA is congruent to triangle BDA. And the reason would be angle, angle, side congruent to angle, angle, side. Okay, again, more than one way to do it. Certainly that's not the only way, but wanted to show you those different reasons. So good luck with this. Let's ask, keep on asking, really. You got to get good at marking your givens, identifying the freebies, coming up with a plan, and then from there, once you do that, it's about knowing your proof terminology sheet and being able to put those steps in the right order. Okay, so good luck with the next two assignments. Talk to you soon.